I'm Josh with Woodland Mills, and I'm here with our HM130 sawmill. And for our 10th anniversary edition, we've rebadged it as the HM130MAX. Now the reason we've called it the Max is because we've now taken the 30-inch maximum log capacity and matched that with our throat opening. So now we have a 30-inch wide cut as well as a 30-inch log diameter. So that'll give you the ability to take this mill and slice right through your 30-inch diameter logs and take off those wide live edge boards everyone's talking about. Now I want to go through all the features and benefits of the mill, and I want to start with the track. Our track system is an L channel, so we use a 4-inch by 2 1/4 inch L channel. This is steel and it's got a milled finish across the top, and that gives us a consistent rail height. You'll see our logs, or our carriage stops at the end. They're adjustable to true the carriage so it hits the end evenly. You'll also see our leveling feet. And the leveling feet, there's 12 leveling feet on a standard sawmill length. And that gives you the ability to level the track system within 4 inches. So there's 4 inches of adjustment in each of the leveling feet. So your base, today we've got it set up on some 8x8 timbers, and those 8x8s had to be within 4 inches of adjustment for us to get this level and square. Now I want to talk about the bunks. So the end bunk here will never see any logs. It's here to keep the track width consistent. But the first bunk that's going to see a log has got a stainless steel top on it. This stainless steel top reduces friction, so it gives you a really nice wear surface as opposed to a painted or powder coated finish. You also can't rub this finish off. This is stainless. We've got our built-in minimum backstops. So within this bunk cover, this is your lowest cut. So when you're down doing your last cut on the board, you can butt the cant into this and take that off without having to worry about hitting your log supports. With the log supports, it's going to come with 2 lengths. There's short log supports for when your track system is located tight to the ground. So if you're installed on a hard surface, tight to the ground, these long supports are going to run into the ground well before you're down to your minimum cut. So we provide the shorter log supports so that you can get down and do your last cuts without running the support into the ground. As we move along here, you're going to see one of the 2 log clamps. And these log clamps ride on a steel bar. They let you push them and pull them. And then as you apply load to the clamp, so this is a quick lock, you push this into the side of the log, and then this has a cam in it, and that cam is going to actuate this log support and snap it into place. So that cam action is a quick lock. It pushes the log against the log supports and holds that log firmly in place. We also have a backup lock here for transport and storage. Now with our normal setup, it comes with 2 log clamp assemblies. You'll see them installed here. With this standard track setup, we've got about 13 feet of track. We can cut just over 10-foot logs down into lumber. Additional track extensions can be purchased. They're 6 foot 5 inches each. And they're going to let you, well, the first one will let you take it from a 10-foot cut to a 16-foot 5 cut, and so on and so forth. So you can keep on adding those extensions depending on the material you have to work with and the finish lengths you're looking for. As we move a little further along, I'm going to come to the carriage, and I want to talk about how the carriage interacts with the track. So we've got our machined wheels here. You'll see they've got a radius cut into them as opposed to a square bottom. And this radius hones in to the top edge of our tracks over time and gives us a very consistent grip on the track. We also have stainless steel sweepers. So this is a wear item, these wires, and they rub into that groove and they keep all the sawdust out of there. Because of their length and their material, they're going to last the test of time. These aren't going to wear out on you, and you can adjust them in and out over time to make sure they're doing their job correctly. Inside of here, we have a dual race sealed bearing. And what that does is it gives our wheel, or this roller, it takes away its ability to rock. So if it was a single race bearing and you side load it, you can get a little bit of wiggle. With a dual race bearing, it's got a firm grip on the track. These wheels you'll see are bolted within or to the inside of our laminated plates. And the laminated plates here, these are laser cut for precision, and we use them to clamp our saw head posts. So this is a 4-post design. We've got 2 by 3-inch rectangular tube, and again it's clamped rigidly between these plates and gives us a laminated structure that holds firmly at the bottom. Because our wheels are on the inside, it also clears the way for a big space between your posts. And the reason that's beneficial is if your logs are crooked and you're really trying to push this to the limit, you're not going to run into your post, because we have just over 38.5 inches between our posts here. Next, I want to talk about the rear of the saw head. So I'll come through here. And we'll see how the rear post is also the 2 by 3 rectangular tube. And again, it's pinched between our laminated plates. Now I want to cover the back beam. We've got a 1/4 inch thick plate. It's been bent to give us rigidity in the back here. So 1/4 inch thick steel. It's bent, and that gives us a lot of stability and rigidity in the head assembly by connecting the back of the 4 posts. We have a small hour meter here, which is going to give us our run time on the engine as well as our run time on the mill to keep track for maintenance. As we move up to the top, you're going to see our top cross support. And first I want to talk about the thickness of the steel we're using. So you'll see this is all laser cut steel, 3/8 of an inch thick. And we use the 2 pieces, and you'll see as you follow me forward, again, they're clamping both tubes, the forward and the rear. And as we get to the front, you'll see that we've actually passed the top support right through these plates, and we've welded them all in solid on all faces. And again, this is for rigidity. So heavy steel welded to give it rigidity, so when you're putting this mill to work, it's not going to shake on you. In this section, we've got lifting loops. So this is for lifting the mill head safely and securely, so you know where to do it and you got a good balance point. Now I want to move around to the front of the mill and talk about the blade lubricant system. So we have a 13-liter aluminum tank. So we have aluminum because this thing's bound to be left outside. Aluminum's unaffected by UV rays, and it won't degrade over time. So because it's a solid tank, we give you an indicator for the level of fluid within the tank. You'll see the filler cap here has a chain on it, so when you're filling it up, you don't have to put it anywhere else. This runs in, and we've got a needle valve in here. So our needle valve controls the flow rate of that lubricant as it hits the blade. So depending on your conditions of your cut, you're going to be able to set this and lock this in place. And again, that sets the flow rate. So from a fine drip to a steady stream, and that's based on what you're milling, how sappy it is, how dry it is. You're going to need to change your lubricant based on those conditions. Now we recommend water with just a little bit of soap. And what that soap does is it breaks up the surface tension so the water doesn't beat off the blade, it sticks to the blade as you're going and gets pulled into the cut. In the winter months, if it's below freezing, you can use windshield washer fluid so it doesn't freeze in the tank. From here, we're going to follow the line down and we're going to see our auto lube system here. So this valve, this brass valve, is actuated by the throttle cable. And as this plunger goes, we'll look down here and we'll see the stream starts. So with this auto lube system, we've used the engine's throttle linkage to activate it. So we kept a single cable coming from our throttle control, and we've kept the effort the same, and this just gets hit right at the last second as the engine revs up to full throttle, so you don't waste any of the lubricant before you're cutting or after you're cutting. You don't have to think about it, you just hit the throttle and this will be engaged and you start your cut. From here, you'll see the line runs down into a brass fitting that's carried through our guide support here. And then it comes out the side of the guide support where you saw the fluid come from. Next, I want to open the guards and we'll talk about what's inside. We've got a locking screw in the middle here. And then there's 3 small draw latches. So behind the guards, you're going to see our hinges allow them to get right out of the way for you. It's easy to get in here and work. Our hinges are outside perched. We've got nylon spacers in them so they don't squeak and they stay tight for you. Inside, first you're going to see our 19-inch diameter cast iron band wheels. So again, 19 inches in total diameter, cast iron. We've got dual sealed bearings pushed in from the back. So these bearings, there's a circlip here. There's 2 of them stacked in from the rear of the cast pulley, and that carries the load and the tension of the blade back into the back beam of the mill. On this side, you're going to see again our 19-inch band wheel, but you're also going to see our idler. So this is our belt tensioning idler, and you'll see our device for tightening our belt. So now our motor stays stationary, and to put the proper tension on the belt, you're going to loosen this bolt and loosen the locking bolt and pull these 2 together until you achieve your proper tension, and then you can tighten this one up and tighten this one up after to keep it there. We've got our centrifugal clutch. So this spins independently of the engine when the engine's at idle, and then as you throttle up the engine, the clutch engages and starts the band wheel spinning. We use a cogged V-belt, and the blade rides on the back of that V-belt. So the belt does 2 things on this mill. It cushions the blade against the cast iron band wheel, and it's used as the drive to drive the blade itself. I want to talk about the blade guides. So these are a machined aluminum guide. They've got a hardened steel block on the top and the bottom, and we use stainless steel set screws to hold those tight. Now, when these hardened steel blocks get set up, they're actually set up with a clearance to the blade, a clearance to the top and a clearance to the bottom. And the reason for that is they're just there to catch the blade if it runs into something it wasn't expected, or if you're pushing the blade faster than it can cut and it doesn't know what to do, it's going to want to wander. So these are there to catch it in the upward and the downward direction. And again, they're set up with a clearance to the blade itself. If we can come under a little bit, I can show you the high-speed roller bearing that we run on the back of the blade as well. So maybe we can get a close-up of this, but it's a high-speed roller bearing, and this is to catch the blade if it tries to move back. So a properly tracked blade is going to run in the middle. That bearing is set up with a clearance to the back of it, to the back of the blade, and then in the case that you're pushing the mill faster than the blade can cut, the blade's going to want to get pushed back, and we need something to catch it so it doesn't come off the band wheels. And it's going to keep that pressure on the blade straight as you work it through the cut. So these back bearings are there for that purpose. And you'll see this whole blade guide assembly is adjustable in and out with a locking bolt that's located here at the back. So it's hard to see from this angle, but it's just tucked in here. And that lets us move this in and out to set our clearance to the bearing. This little bar in the middle here is to stop us from running into our log supports. So it's designed to be set up to interfere with our log support before our blade does. And it's tunable with this bolt here. So it actually protrudes out the rear. You can adjust it in and out, and you can adjust it so it's going to interact with your log support before your blade does. While I'm in here, I now want to talk about our adjustable blade guide, this auto locking feature. So you'll see the indexing holes along the back here. We have an indexing plunger here, spring loaded, and there's an adjuster. And this will show you the features in the handle when we get around to the back. For now, I'll just push it out of the way. And I want to show you the measurements we're left with here for what you're able to cut with the saw head. So in total here, we have about 30.5 inches between the guides for a 30-inch cut. At that 30 inches, you can cut a 4-inch thick slab off the top. And then you're going to see we have a slight taper here. So with that slight taper, we're going to be 7 inches of maximum cut to a width of 28 inches at the top taper. You'll see the blade I'm referring to or measuring to here. This is a thin kerf blade. It's 1.25 inches, 42 thousandths of an inch thick. And that always refers to the thickness of the back band. And then the teeth have a pattern in them. So they have one tooth set upwards, one tooth set down, and in the middle they're going to have a rake tooth, which is straight to clean the sawdust. And the set of those teeth is determined by the blade and the manufacturer. But that clears the way for the 42 thousandths back band so it doesn't get pinched as it goes through the cut. Next, I want to go around and talk about the back beam, which is the structural member that holds all these parts of the sawmill together. And I want to go over why we use a welded steel assembly made out of rectangular tube, and I'll show you all the contact points it has with the various components I've already shown. So first I'll start with the adjustable blade guide. It bolts into this back beam. You'll see the back beam is a rectangular tube that spans the whole length of the sawmill. It carries our blade tensioning system as well as our tracking. As we come along, you'll see it carries the engine mount, is all welded in. We've got the back bolt that is part of the belt tensioning idler. And as we come further along, we have our tracking system for the drive wheel. Now again, it's all welded steel, and that's because all the blade's tension as well as all the engine's horsepower basically gets applied to that back beam. So it's really important that it's strong and holds true once it's under load. With the adjustable blade guide bolted in here, I want to cover a few features like the stainless steel rollers. You'll hear that indexing plunger, which is located on the back of the assembly. And then you also see our sealed bearings, which are pushed inside of the rollers. And then we have an offset lobe here, which allows you to tension the pressure between these rollers and keep this assembly tight and running true. If we look up here, we're going to see our RapidChange blade system. And what this is this keeps the tracking and keeps the blade alignment true while you're detensioning and retensioning the blade. So when you're changing blades, it's as easy as just removing the tension with a few turns. It's toolless. The blade's going to slide off the band wheels. The new one goes on. And then we're going to re-tighten this. Again, no tools. And once we're flush here, we've got our blade tension set and we're ready to mill again. What I'm tightening up in here is a big stack of Belleville washers. So Belleville washers are conical washers that act as a spring. So we've got them in a configuration that allows them to act as both a cushion for the blade, and by measuring their deflection, we can set our blade tension consistently. And the reason we went with these Belleville washers over a traditional rubber or a grommet is because they give us consistent results both in winter conditions and in summer conditions. So they're not affected by the temperature. Now I want to go on and talk about our engine option. So bolted to this back beam, we've got a 14 horse Kohler electric start engine. The electric start comes standard. The battery box is included, but the battery itself you're going to have to buy locally. It does have a recoil starter on it, so it's ready to go as a regular pull start engine with the electric start built in, and the key is just tucked up in the back. Now I want to go over our auto locking saw head and its features. So this handle gets pushed in. You can raise and lower the saw head. And this handle is coupled with an Acme lead screw. And that Acme lead screw is housed back here, hidden by our back beam. And on this, we have a set of pulleys, machined pulleys, and our stainless steel cables ride on those. And what this gives us is a very consistent change in height for every rotation we do. So there's two ways to keep track of your board thickness. We have a traditional log scale, and we've got our magnetic log scales on here. So we give two magnetic log scales. We keep one stored in the back. And we have full 1-inch boards and 2-inch boards. We also have a 4/4 scale and then a standard ruler scale. We have a way to zero this. So when you set your base cut, you're truing it up off the bunks, you can set your zero. But then we also have the ability to count turns. So to keep track of our boards, if we know that 2 turns gives us the board thickness we're looking for, it's as simple as 2 turns and lock, 2 turns and lock. Again, we use stainless steel cables. You'll see they're routed over machined pulleys. We've got sealed bearings pushed into all these to keep it running nice and smooth. And again, the stainless steel cable is rated for well over the working load here, so it won't stretch and change the accuracy. Next, I want to talk about the throttle system. So you'll see our throttle handle here. And this is what engages, obviously, the engine throttle, and it also engages our auto lubricant system. So when this is all the way down, you're going to be ready to cut. The engine's at full throttle, the clutch is engaged, and then when you release, the clutch disengages, the lubricant stops, and you finish your cut. You can take the board off. You'll see this is attached to our handle, and our handle has quite a bit of adjustment in it. So when you're in a ground mount position like we are now, it's nice from a user to have one hand here. It's a comfortable height. Depending on your height, you can adjust this. It'll rotate backwards. And then if you are to raise the mill or have it in a trailer, you're going to be able to rotate it a full 180 and have the throttle down here, because now that track and mill is going to be raised up to make it ergonomically better for you to use. On the far side, we keep our assembly manual for both the sawmill and the engine. So Kohler's manual's in here as well as a safety kit with glasses, earplugs, and gloves. And in that, it's going to tell you all the maintenance requirements for the engine and what you should do to keep your sawmill running at its best. In conjunction with that, for oil changes, with the hour meter on there, it's going to let you keep track of the hours on the engine. It's also going to let you keep track of the hours you're getting on your blades and the sawmill itself, so that wear items can be replaced at proper hour intervals. For changing the oil in the engine, we've extended the drain plug so it clears the engine mount for you to make it nice and easy to change the oil and to capture that oil so it doesn't run down all over the sawmill. Now that we've gone over all the features and benefits of the HM130MAX, I want to load a log on here. We're going to load a log that's close to its capacity. We're going to get this mill started and show you how it mills. I want to do a bit of a recap over the details of the log we just milled. So we got 9 live edge slabs out of that, ranging from 24 inch in width up to about 28 inches in width. You'll see during that whole process with those larger logs, it's nice to have the 2 log clamps there so we can really draw it in against the 2 log supports. It was also nice to have the wheels on the inside of the carriage to give us that space between the carriage posts so we could fit that larger log through there and really utilize that 30-inch throat opening. We've gone ahead and put the HM130MAX on our Woodlander trailer. In its standard configuration, the Woodlander will let you cut just over 10-foot logs into lumber, and in the XL format, it's going to let you cut just over 16-foot logs into lumber. The benefits of taking it and putting it on a trailer are going to be mobility, so you can take it to your work site, and then at the end of the day, you can put it away for storage. You're also going to benefit from the rigid frame and the quick setup and leveling. So with these 4 jacks in the standard configuration, 6 in the XL, when you pull up to your work site, it's just a matter of a level, crank those jacks, and you've got your elevated work platform level and ready for a log. And then the increased ergonomics. So it's much nicer to work around the mill, and you'll see that later when I'm actually putting it to work for doing all the log clamps as well as the log supports. It's at a nice elevated height to work at. Now I want to start at the front here, and we'll work ourselves through the construction details of the Woodlander trailer. And we're going to start with the 2-inch ball and pin for the trailer. We have a 4-pin connector which works the lighting. We also include the safety chains to attach it to the tow vehicle. As we work our way back, you're going to see our laminated plate design. So we have 1/4-inch thick plate, and it's been bent for rigidity and also to give us a surface to pick up on our lower cross supports. So you'll see at all the bunk locations, we've added a lower cross support for rigidity, and it also creates a box beam to give us lots of stiffness in the left-right dimension, and then the lamination of the side plates on top of our already 1/4-inch thick rails gives us the rigidity along the length of the mill. As we come around to the front, we include the 4 jacks in the standard configuration, and you use these to raise the mill off the tow vehicle as well as to level the Woodlander. You'll see there's a release pin here, so during transport these are rotated 90 degrees. When you buy the Woodlander trailer, it's going to come with 4 locking brackets that get integrated into the head or the laminated plates on the head of the sawmill. And these give you a locking pin, so there'll be 4 of these brackets and 4 locking pins. And they get integrated right into the main shaft of the wheels. And what this does is it locates the head on the trailer to give you the proper tongue weight. And it also secures the head down to the tracks. Now we also include a ratchet strap as a precaution to keep that head down on the tracks, and then these pins will stop it from moving around as you transport. As we go a little further back, you're going to see what we've done with the mill head and the handle. So this handle has multiple positions in adjustment, and when we're up on the Woodlander trailer, we spin it back to give us a nice working height when we're milling. The fenders are removable. They've got a locking pin as well as a clamp bolt in the back. And these are going to come off and get out of your way when you're loading logs as well as when you're milling, so they aren't in the path that you're walking along the side here. The tires are DOT approved trailer tires. We've got standard trailer bearings with a grease pack. They're on torsional axles. And the torsional axles allow the tires to move independently left and right. So when you are off-road or in rough terrain, these tires act independently of each other, and it keeps a much smoother ride for the trailer. As we come to the back, you're going to see the lighting kit that's on here. Although the Woodlander is sold as an off-road trailer, we do include various components to aid in its registration as a home-built trailer in your own jurisdiction. We have the 2-inch ball receiver with locking pin. We've got the double chains and hooks. We have the 4-pin wiring connector for the tow vehicle. We have running lights as we work our way down the side. We have the removable fenders, the DOT approved tires, and the torsional axles. We have the side running lights at the rear, and then along the back we have the license plate holder, the license plate light, as well as the signal lights for the back. So next we want to get a log on the mill and show you how this all works. But first I have to get this last locking pin out. We'll get the saw head back. And I want to talk about how to get logs up on the Woodlander now that it's at this elevated height. So we are going to have 2 options to get logs onto the mill. We can either use a ramp and a winch, which we have as an option for the Woodlander series. The ramp and winch has storage positions within the trailer, so it transports as a complete package. And that's going to be our preferred method today. Alternatively, we could use a tractor to just set that log right on the bunks. With the bunks raised over the track, it's nice and easy just to come in, lower them down, and pull the tractor forks out, leaving the log on the bunks. So with the head back, we need to get the fender off. I'm going to go ahead and get those log loading ramps, and we'll get a log on the mill. So we've got the log secure now. I want to talk a little bit about this log. It's a 18-inch diameter at the smaller end. It's about 20 inches at the butt end. It's 9 feet long. It's a red oak log. It's been down for about 2 seasons. And now I want to get the mill fired up. We'll line up our first cut and show you how it all works. So we finished the last cut. We calculated this out at about 90 board feet of red oak. We started there with some live edge slabs to get us down to a square, and then we took off some wider planks, 11 inches. We got into some 7.5 inch ones, and then the finals were about 5.5 inches wide. I was rotating it. I saw some imperfections in the log, in the grain, and I was trying to rotate them out and get the cleanest boards I could as I got my way through. Next, I want to talk about how this mill is packed, shipped, and delivered. So when you purchase the sawmill and the trailer together, the trailer comes in its own steel crate with a cardboard sleeve, and that's going to be put up on top of the sawmill crate, bound together, and we're going to ship them out of our closest warehouse location to your address. They're going to come by transport truck, and where available, we offer a tailgate delivery service, which will take it down and place it curbside for you. This has been Josh with Woodland Mills. I hope you've enjoyed the video of the HM130MAX and the Woodlander trailer series.